I'm sure by now you can plot the graph of quadratic functions. The graph of a quadratic function has its roots where it touches the x-axis. However, the graph usually gives approximate roots. This means the roots from the graph are usually close to the roots obtained using the method of factorization, but may not always be exact. Whenever we calculate the roots of a quadratic equation from the graph, there are three possibilities. First, the curve of the equation can cross the x-axis at 2 points. Other times, it only touches the x-axis at 1 point. And finally, it may neither touch nor cross the x-axis. Now, let's take a look at a question that illustrates the first case. Construct the graph of equation y equals x squared minus 2x minus 3 using the range of x from minus 2 to plus 3 and a scale of 2 cm to 1 unit on both the x and y axis. Hence, find the roots of the equation using the graph. Can you remember the first thing to do when plotting the graph of a quadratic function? We make the table of values. So, the completed table looks like this. And our final table is this. Next, we plot these points just as we were taught in lessons on plotting the graph of a quadratic equation and get this graph. From the graph, we can see that the curve crosses the x-axis at points minus 1 and plus 3. Therefore, the roots of the equation are minus 1 and 3. It's as simple as that. Now, let's have a look at when the curve only touches the x-axis at 1 point. We will illustrate with the quadratic function y equals x squared plus 4x plus 4 with a range of x from minus 3 to plus 1 on a scale of 2 cm to 1 unit on the x-axis and 2 cm to 2 units on the y-axis. Now, plotting the points and drawing the graph, we should have this. And from the graph, do you observe that the curve of the function only touches the x-axis at 1 point, which is minus 2? Whenever this happens, it means that the equation has double roots. That is, the root is repeated. Therefore, the roots of our function are minus 2 and minus 2, since the curve touches the x-axis only at minus 2. Finally, the curve of a function may not cross or touch the x-axis at any point. For example, in the quadratic function y equals x squared minus 3x plus 3, let's draw the graph with a range of x from minus 1 to 4 and scales of 2 cm to 1 unit on both x-axis and y-axis. When we construct our table, we will have this. Now, plotting the points and drawing the graph, we should have this. Here, the curve neither touches nor crosses the x-axis. What could this mean? It means the equation has no real solutions, or its roots are imaginary. This is because there are no real numbers for the value of x such that it satisfies the equation. Let's do a recap on what has been learnt in this lesson. First, graphs give approximate roots of quadratic functions. Next, whenever the curve of a function crosses the x-axis at 2 points, we get the roots by taking the values on the x-axis at the 2 points where the curve crosses the x-axis. Lastly, when the curve neither touches nor crosses the x-axis, the quadratic function has imaginary roots. Hope you got it. It's very easy. Don't you think so? We will see how to go in the opposite direction in another lesson.